Good morning, everyone. Welcome to this webcast in the STEMnet webcast series. This is NSF, Rapid, and EAGER Grantees. I'm Jennifer Wicks, your host behind the scenes from Learning and Development. Glad to be part of this team to support this series. And want to welcome you and ask you to please do put your information into the polls that we have on the screen. Would like to know what you're most interested in learning in this session today, and also which campus you're joining from or you're representing today. We also look forward to your questions and comments throughout the webcast in the chat pod, and we'll have that direct caption link for you in just a moment. I'll paste it into the chat pod for you. And with that, I would like to introduce our Executive Director of STEMnet from the Office of the Chancellor, Dr. Frank A. Gomez. So Dr. Gomez, I'll hand it over to you to get started.
Thank you, Jennifer, and for the kind introduction and warm welcome to all of you out there. I hope you and all your families are healthy and safe. It's great you can join us today for our webcast on NSF Rapid and EAGER Grantees. This marks STEMNet's 21st webcast to the CSU community. Today we highlight several grantees funded by either the NSF Rapid Response Research Rapid or Early Concept Grants for Exploratory Research EAGER mechanisms. The RAPID funding mechanism is used for proposals having a severe urgency with regard to availability of or access to data, facilities, or specialized equipment, including quick response research on natural or anthropogenic disasters and similar unanticipated events. PIs must contact the NSF program officer first, whose expertise is most germane to the proposal topic before submitting a rapid proposal. This will facilitate determining whether the proposal is appropriate for rapid funding. The EAGER mechanism may be used to support exploratory work in its early stages on untested but potentially transformative research ideas or approaches. This work may be considered especially high risk, high payoff in the sense that it, for example, involves radically different approaches, applies new expertise, or engages novel interdisciplinary or disciplinary perspectives. These exploratory proposals may also be submitted directly to an NSF program, but the EAGER mechanism should not be used for projects that are appropriate for submission as regular non-EAGER NSF proposals. PIs must contact the NSF program officer first, whose expertise is also germane to the proposal topic prior to submission of an EAGER proposal. This will aid in determining if it is appropriate for an EAGER mechanism. Before we begin, I want to remind the audience to use the open chat box on the screens to type in questions they may have for our speakers, who, when not presenting, will make every effort to respond in real time. So let's begin. It's with great pleasure to introduce my good friend and collaborator, Dr. Blake Gillespie from CSU Channel Islands, who will speak on Reimagined virtual STEM laboratory experiences in response to COVID-19 pandemic. Blake, the floor is yours.
Hi, everyone. Thank you so much, Frank. So in this project, STEMnet brought together faculty from across the CSU to share ideas for developing tools that support the pivot for COVID. And particularly in one of its more challenging aspects, which is the delivery of online labs. And ultimately, STEMnet settled on 3 of those projects to move forward with for this submission. And just to motivate that work a little bit, we fast forward to something we might be experiencing now. For me, as a chemist, in my own department, we see students entering upper division labs having missed all of their general organic chemistry lab training, hands-on lab training, so they might not have ever touched a piece of lab equipment or glassware. Just puts in perspective how important it is that we think creatively about distance labs to move beyond sort of commercially available tools that we have relied on for the last couple of years now. I'm just going to briefly introduce my colleagues. The group of faculty that we worked with was across a few campuses, starting with Dr. Shirley Yap at CSU East Bay, who's a mathematician, Dr. Kalori at San Bernardino, she's a physicist, and I'm a chemist at Channel Islands. And Dr. Gomez's strategy was to unite us through the addition of a 4th element, that's Dr. Jane Lair. She's the director of student research and a professor of ethnic studies at Cal Poly San Luis. And her student, Sejal Kargal, just graduated with a BS in engineering. So the hot takes here is where I probably need to spend most of the time. In terms of what the insights from grantees, It's Dr. Lear who really provided a cement for our proposals. I myself have written lots of collaborative interdisciplinary grants, but usually that kind of teamed experience with the educational literature, which is relevant to this project, might be kind of sparse or maybe focused on our individual interests or expertise. But Dr. Lear brought a depth of familiarity that really enriched the writing process. And in general, I would say the writing process in this kind of work is really fun and generative. The hot take here would be some kind of glue person that for an element of all the collaborative projects, that's going to be important for me moving forward. It allowed us to create a context that makes our proposal stronger. And for us, that was connecting inclusivity of the tools to disaster preparation and response. Yeah, and that really resonated with reviewers. In the pivot, we collectively, education, sort of decided to ignore what we know about distance learning that it usually leaves behind lots of historically underrepresented populations. So our decision was to center inclusivity and make that a strength, and that's both in the ideation and articulation of the project. So let's see. Her presence, Dr. Lear's presence, extended to the elements of project evaluation as well, and that's going to be important as I wind up the talk in a few minutes. It was a non-standard approach to sort of external evaluation that we might all be familiar with. Another important idea was being careful about identifying what good targets are and what more challenging targets are. Speaking critically, for rapid, a careful identification of a good and difficult target is really important. And I'll say that for the 3 projects that we proposed, 2 were pretty straightforward given the timeline, with an asterisk, which is to say they were both also very hard to create as well with a lot of energy. But the third, and that's my own project, provided a lot more challenges that we're still trying to learn from. So I'd say here that asking yourself about infrastructure challenges that you might face with your project is really important. And for me, that winds up being students' access to laboratories. So not only in terms of campus policy, but also in terms of student willingness. I just judging from my campus's parking lots, a lot of students are still reluctant to come to campus. So that's been a challenge. Briefly circling back to Dr. Lear's work, I just wanted to mention again the idea of the project evaluation included something called UX, which is for the user experience. Many of you are probably aware of this. I wasn't, but that was the center of her evaluation, and it really made the inclusion of students as consumers as an arbiter of our tool's effectiveness, and that includes not only the ease of navigation of the tasks, but also the perception of the student's own learning. So I think that it's an important part of the evaluation of how a tool is going to work, and it's an effective way to also begin to try to address your grant's DEI goals, which probably most of them will include. Okay, I'm going to quickly look at a couple of the slides of the colleagues' work. They're not here to represent for themselves, so this is a sort of a snapshot of Dr. Yap's work. Involved a lot of code writing that allowed students to access public information databases in real time. So she has very interactive tools that students use to learn how to analyze data that support them in the analysis of data. That's really important for the inclusivity of the project as well. But using a target that's highly relevant, and that's the distribution of COVID cases. So it supports students' conceptual understanding, but is very centered on the now. And it's also really flexible in terms of application to other public information databases that might be relevant in the next challenge that we face as a society. Briefly, Dr. Kalori's project, she teaches an intermediate physics lab, which she typically runs as a course-based undergraduate research experience. I'm sure you're all aware of those. But the challenge here was how to help students develop projects that they could do from home, and with tools that they mostly have at home, although she did support them, I think, with certain pieces of equipment. But for the most part, they're on their own in developing these. So this is really fun, and in this case, we're just looking at one project in which a student was measuring the elastic modulus of a gel as a function of temperature. There's many other projects, this leverages the student's own creativity as well in the development of their own learning, which is also a really powerfully inclusive tool. Mine would be the last project, and I mentioned that it's one of the challenges, but this was a choose your own adventure virtual lab for an organic synthesis. And the key here is that we want to create architecture that allows the creation of a branching video that could be ported directly into our learning management system, from which we can gather student decision data for later analysis. So there was a fair amount of software development for the generation of the content that could, not only the generation of the content, but the creation of the package or framework for gathering student information. And that's all before we even began shooting video. And all I'm going to show you of that, I have a little clip if I still have time to show it. Can I bring the video up? There we go. I'll let somebody else do that. Or am I doing that? Okay, cool. Oh. See, I just keep my hands off. Can somebody?
I'll just bring it right back up here, Blake. Just
Stop doing
moment.
what you're doing.
Yeah, no problem.
Dr. Gillespie. Okay, so
there we go.
This is kind of the centerpiece visually of the labs, which is a big color change when this is a synthesis of a still beam. So here we go. Just showing you that the key idea here is that students in this kind of project can explore the parameter space of a problem way more broadly than they can in a laboratory setting, which in 3 hours they have to basically follow the recipe, which is obviously not how science is done. And so in this case, I'm just showing you how we can follow the same reaction with different kinetics at different temperatures, which allows for a subsequent different kind of analysis as well. So I'll just stop that and move it away. And I guess the last thing I want to share, I don't see the hook coming out yet, is coming back to that user experience. So this is just a cartoon that gives an overview of that. And in this kind of work, a student runs through the exercise, whatever it happens to be, in the presence of a facilitator that's scoring the student's experience. And a really interesting facet of this is that a very small number of users is sufficient to find all the challenges that a student might encounter. That can be as small as 5 before there's some point of diminishing returns where that's no longer useful. So just pointing out that user experience analysis can be useful as a tool for improving the product in the case of my own work, but also as a way of assessing the product and also assessing how it might be useful for a range of different student populations. So, and I guess I'll just wind up by saying, again, the kind of collaboration that we took on, which is very broad, is very rich in terms of just grant writing and ideation. The creativity really flows, and there's a real synergistic effect of having that diverse representation, both disciplinary and otherwise. And the careful choice of personnel was really able to buoy this proposal up. So thank you for your time.
Great. Thank you, Blake, for that nice summary of our work. And certainly it was, writing all this in the really the heat of COVID-19 was imaginative, and I wouldn't say it was difficult, but certainly it was a new way of writing a proposal, certainly being on different campuses, which is one, but also in the midst of COVID-19 before there were vaccines and what have you, was certainly an interesting way to work together. We have a question here. How did the collaborative writing process affect your work? So this is a writing process where everybody, there was the framework that we were creating, which I referred to before, which is how to make these proposals relevant for the grant reviewers. And that was a really interesting process of learning for all of us about how to tie things together. But for the individual projects as well, there was a lot. It wasn't just like I'm plopping my section in, right? There was a lot of discussion about what that should look like, what that could look like, how to address that to this framework that we've all agreed upon. So I think, again, it was really generative. I've used that word a couple times now, but it was really a really powerful way to think about one's own work in the presence of other people that you don't normally interact with. So you're not just talking about the same things you always discuss, right? You're forced to confront new problems and new ideas. Yeah, definitely. Not only are we forced to work with people that are outside of our discipline, let alone outside of our institution, but also people that we likely have never met before. And so there's that need for better words, that type of familiarity, that dating type of stage, where you have to really become used to the nuances of people that they may be 10 minutes away, or they may be 5 hours away, and you don't know really what they bring to the table. But fortunately, with this group, it worked out for the best.
I would certainly echo that, and that I've been really inspired by working with all my new colleagues.
That's great. That's great. So thank you, Blake, for a nice presentation. And if there's any questions in the chat box, hopefully you can respond to them. Okay. So our next speaker is Cueponcaxochitl Moreno Sandoval from Cal State Stanislaus. Her presentation is entitled "We Are the Earth: Ancestral Computing for Sustainability." Cueponca.
Thank you so much, Frank, and thank you, Blake, and to all of the organizers of this STEMnet gathering. I am very happy to share with you some of the work that I've been engaged in for the past decade around ancestral computing for sustainability. And I'll explain a little bit more about what that means. My name is Cueponca, and I am Kashkan, Chicana, Izcaloteca. My family is from the Sierras of Zacatecas, Mexico, and came to the United States as braceros in the 1950s and 60s, and have stayed. And so I come to share some of this work not only as an academic journey and professional one, but because of my lived experiences intergenerationally with my family and my ancestors. And so I come to computing education as one that is very attuned to the ways in which computing has systematically denied a seat for people like me to make decisions about how computing education should be unfolded in our public schools. And I come to computing education also as one that absolutely believes that there is the possibility of using computing as a leverage for social change, as a tool for nurturing a world where many worlds fit. I'm an ethnic studies assistant professor of Native American and Mexican Indigenous Studies at Stanislaus State. And my dissertation work at UCLA was around bridging, interweaving ancestral knowledge systems, otherwise known as indigenous epistemologies, and computer science education for the greater purposes of protecting the earth, protecting social sustainability, and economic sustainability. And so we engaged in creating curricula that was culturally responsive at the K-12 education school in the greater Los Angeles area, and it's been adopted nationwide and throughout the whole state of Puerto Rico. And we are engaged in finding ways to enter computing education from an epistemological approach that is willing to create a world that we have not seen before, as a way of stemming from the time immemorial practices of ancestral computing that people from all over the world have engaged in complex problem solving, in computational thinking. And what happens in a Eurocentric approach to learning is that Eurocentric ways of understanding the world are centered in its epistemological production. and all other populations are relegated to the side or seen as less than. And during my visiting scholar position at UC Santa Barbara with Animal Tlatoque, bringing together Chicano studies with computer science education, I saw that there was that hierarchy of knowledge production, and it was a very difficult situation to run into. And so I was approached for this EAGER grant proposal by researchers at the University of Puerto Rico and Rio Piedras, who have a longstanding relationship with the National Science Foundation, and who had this idea of how can we engage in culturally responsive computing education at the higher education level. And we gathered researchers from other universities, like a historically Black university, the University of the District of Columbia, as well as researchers at the College of Education in Maryland, and the Director of Native American Studies at Northern Michigan University. And we came together to establish a network of researchers. We are all Black, Indigenous people of color, and we are all engaged in revitalizing our ancestral knowledge systems in our day-to-day life. And we look at computer science education, as all of you have, and we see the disparate participation of women of color. We know that women of color, as I mentioned earlier, are systematically denied a position in computing because of the historical approach that computing has taken. A child of war, a child of a warmongering and imperialist way of thinking, but certainly one that has the potential and the power to shift, to engage in critical awareness around issues that are important for dignifying the experiences of all people. The research that we propose and that we are engaged in is a community-based participatory action research that looks at our own positionalities in relationship to the research that we're interested in. We're interested in looking at how might these ancestral knowledge systems that we are engaged in and also opening a conversation about, and computer science education co-create positive learning ecologies for marginalized communities, especially women of color, towards sustainable computer science practices. We have made a call out for women of color studying computing to gather with us and in different gatherings across the United States. We initially started with 3 gatherings where we would invite students to come virtually, and we would discuss issues around their experiences with computing in higher education. Most of the ones that we have interviewed in California are computer science majors. And this is also a participatory action research in that the participants themselves are invited to be co-researchers with us and co-authors with us as the faculty who are engaged in broadening participation in computing. And I'll let you hear for a couple of seconds the voice of one of our researchers.
Hello everyone, my name is Marlon Martinez Lopez. I am a computer science and cognitive studies major at the California State University Stanislaus. I've been working with Dr. Cueponcaxochitl in a research project called Ancestral Computing for Sustainability. As a research assistant, I've been working with research writing to data analysis with Dr. Cueponca's guidance. I've had the pleasure to be working with such wonderful students majoring in computer science or another tech-related field with their experiences in computer science education. With Dr. Cueponca, I've had the pleasure to be working with her and seeing her as my research advisor and also my mentor. I would like to thank her for my growth in not only as a student researcher, but as a student. Thank you for listening.
So much. So we'd like to really, we've collected about 71 and still counting women of color experiences in STEM in general. Other states are focusing on STEM in general. We're focusing on computing in California. And most of the people who are responding identify as Native American with studying computer science and also female. The gatherings are a safe place for female students to share about their experiences. Many of them have expressed gratitude for their communal approach to understanding computing in the United States, and also to which end we would like to see computing include and center the epistemological approaches and understandings of women of color that draw on their community cultural wealth and that are also centering a relational accountability to the land. We have created a research network, like I mentioned earlier. We are engaged in revitalizing ancestral knowledge systems and leveraging computer science as a tool for revitalizing this knowledge. And as I mentioned earlier, is also a safe space for women of color. The recruitment is really self-selected and word of mouth. I mean, we share to as many networks as we can, especially across the CSU, but it really ends up being word of mouth, how students are coming to these gatherings. For the future, we would like to see Indigenous data sovereignty be developed. We would like to see the ways in which CS is conducted and implemented with a purpose. We'd like to see a pathway for ancestral computing for sustainability in the K-12, expand our ACS network, and also center this relational accountability. As we know, the e-waste piles are going nowhere, and the ways in which the e-waste piles unfold toxicity in areas where people of color or the global south exist is really high. We know that computing inextricably shapes our lives. And when we brought in participation, it's not just to increase numbers in the number of women of color who are taking computing, because are we retaining them? But it's really about an epistemological shift in the ways in which we approach computing education that is culturally sustaining and revitalizing towards a more sustainable CS production. AB 1460 and AB 101 have passed, have been created as legislation this year that makes ethnic studies as a requirement for all CSU students and also all high school students across California. So we see that the next wave of education in California is going to have a higher demand for ethnic studies and an interdisciplinary approach for how we learn computer science education, again, interweaving the field with ethnic studies is what my hope is. Thank you, everybody.
Thank you, Cueponca. Very, very interesting talk, and it certainly gives us a lot to bite on. A question here. Your work is very culturally responsive, certainly. What advice would you share with faculty? And certainly this has come to my attention given all the different proposals we've worked on where culturally responsive pedagogy, teaching, learning really is at the forefront. But how would you share with faculty who might be interested but are not sure on how to apply culture responsive STEM education in their courses?
That's a great question. Oftentimes we hear about like trainings on cultural competency, and I actually think that really in culturally sustaining education, the first thing that comes to mind is positionality. How might we be critically reflexive about our position on this native land? I'm going to dare to say that all of California and the world is native land. And what does that mean? What does it mean to nurture our and calibrate our positions in relationship to native land. And then understand how our position impacts the ways in which we teach, the ways in which we process information, and be curious, lean into that direction. There's certainly a lot of work on critical reflexivity that also centers systemic oppression and systems of power in a way that is very transformative. And it's, I adopt the language of what Michael Apple calls the language of critique and possibility. We know we have a lot of work to do. We know that systems of power have been in place since colonial times and pre-colonial times. We can spend so much time talking about the problems, but what are we going to do about it? What are the possibilities? I'd like to think that 80% of my time is going to be really focused on the possibilities. And I invite us all to think about and imagine a world where all worlds fit and where the dignity of all people studying computing education is nurtured and centered. Thank you very much.
We look forward to working with you going forward. Our next speakers are from Chico State, Doctors Sandrine Matiasek and Jackson Webster, and their title is Water Quality Impacts of Wildland Urban Interface Burning.
All right, good morning, everyone. It's our pleasure to be here, and we're going to do a joint presentation. So I'm going to start us off and give you an overview of this NSF Rapid that we received to study the campfire. So before we get into it, I just want to acknowledge that, this is not something we did completely on our own. We were really at the center of this, being close to the fire, but we had a lot of collaborators that really boosted our analytical capabilities that allowed us to be competitive for this funding. So in addition to in addition to many people that helped us at other campuses, we had a number of students that helped. And so this has been a really great opportunity for a large number of students to participate in science, get some field experience, lab experience. So you can see we have quite a list of undergrads and grads that participated. And I also want to take a moment to acknowledge the Center for Water and the Environment. Not only did they help initiate this process and help us with a little funding right off the bat to make sure that we had some sampling taken care of even before we got this award. But also this is a great resource for Chico State, for faculty members to get involved in water and environmental issues. And Sandrine and I are also both the science directors for this center. So we have to throw in that plug and hope that any Chico folks that are watching this might join us. All right. So this, if you haven't heard of the campfire or aren't familiar with it, then let me just give you a quick overview. This fire took place in November of 2018, and it was really an unprecedented fire because it burned very, very quickly. This was about 6 hours after ignition, and it basically at this point destroyed the entire town of Paradise. So there were very high winds pushing this fire very rapidly in this kind of wildland urban interface. And it left in its wake a lot of high burn severity, a lot of devastation across the watershed. But more than anything, it really left this, which was a lot of disaster material left in the watershed. And actually, there's a slight mistake here. That this is not, the photo credit should not go to me on this. I do have some drone pictures, but this is not one of mine. So I have to just say that. So here you can see that there were a lot of homes and cars that were burned, and all this material was left essentially out in the environment for the entire water year following the fire. Not only did houses burn, but there were also a number of downtown type buildings, office buildings, and auto lots and restaurants and more industrial type areas that burned as well. So all of this And I should also say that all of Paradise is on septic. There's no wastewater treatment system there. So not only did 18,000 structures burn, but in many cases, the septic tanks were exposed through burning as well. So there was a lot of potential here for contaminants. In that case, pathogens potentially to enter the environment. There are also many vehicles on the streets, around homes, and you can see in this picture, I refer to these as carcasses. They were all over the place up there, and you can see some of this melting metal. Unfortunately, these images have become more widespread as we have more of these fires, but at the time, this seemed just totally wild and crazy. And you can see in this image, the radiator kind of melting out the front of the vehicle, the lead battery sitting on the street. You have copper wiring harnesses, tire ash. Tires contain all kinds of zinc and other materials that are not great to have in the environment. And so all of this was sitting on relatively impervious surfaces, oftentimes asphalt-lined gutters that would lead right into these streams that are originating in the town of Paradise. So there's a lot of opportunity for metals, pathogens, organic contaminants to make their way through these conduits right into surface waters. And so that's what we were interested in studying, that we saw right away that there was this really unprecedented situation occurring. Just to give you a sense, Chico is right next to where this fire happened. The campus closed down the day this started and was closed for a week leading into Thanksgiving break. So it was about 3 years ago this week. And immediately, we went to our desks and started writing. I think there was a draft of this proposal before the fire was even close to out. Within that first week of the fire still burning, there was a draft to get this going, and we were reaching out to these collaborators to find people that could help us analytically to do this work. And then this proposal was submitted by December. During that time, we'd already done our first round of sampling, and we were out there sampling, essentially immediately to make sure that we had the background samples and that we were doing the work. And that's kind of what it took to ensure that we were well positioned to get this. So with that, I'm going to turn it over to Sandrine, and she's going to talk a little bit about what happened and what we found after getting this award.
Thank you, Jack. Thanks for giving us all this great background and introducing the team here. So I'm going to tell you a little bit more about all this effort that happened in the field and in the lab. But as Jack was mentioning, we didn't wait to get the NSF grant to get started. It was immediately after the fire. It was definitely a rapid response. So we studied 3 creeks, 3 watersheds that varied in amount of burning, from severely burned for Dry Creek and Clear Creek, and moderately or partially burned for the larger watershed of Butte Creek. And then we had a control watershed at the Big Chico Creek Ecological Reserve, which is a CSU Chico property. We also had some sites ranging from pure urban land use to sparsely developed land with the Big Chico Creek Ecological Reserve. So that there was a nice, very nicely well thought out study design there. And then we really went to work capturing all the storms that happened after the fire. And it was a very wet winter, this winter of 2018 and 19. So we collected over 150 samples, basically mostly runoff, but also some base flow. And here is a good little view of kind of this effort here. You're seeing the hydrograph for Butte Creek, so that's the stream flow in the creek, and every symbol here represents a distinct water sample. that we collected. So it was a big effort, boots on the ground with lots of students, and we got lots of interesting results that we're still parsing out. One of them is shown here. One of the interests we had was to study these organic compounds that could have been that were released in the environment from the fire and following those in water. So that's the dissolved organic carbon here. Those are molecules containing organic carbon that can come from both living and burned vegetation, but also from burnt homes and businesses, household chemicals, power poles, and so on. So one of the main things we found here is that at the beginning of the storm season, we saw pretty elevated organic carbon concentrations, but that was kind of throughout all the watersheds, including the control. And this is commonly seen, as the first rains kind of wash off the landscape. What was different was that the control sites throughout the later storms kind of had lower DOC concentrations, but then we saw a sustained kind of consistent release of organic compounds throughout the storm season. So we saw this clear impact from the fire on water quality. This was also observed with nitrogen export. We saw some elevated nitrogen, and that was proportional with the extent of burning in the watersheds. A little bit more on organic analyses. Our collaborators at the University of Washington performed targeted analyses for 35 contaminants, known organic contaminants, representing 6 major classes of known stormwater contaminants, along with suspect screening for over 1,000 organic compounds based on mass. So they detected compounds from a wide range of classes, including automotive, pesticides, industrial, and pharmaceutical compounds. And another trend that was really interesting was that these persisted in the affected creeks throughout the storm season, all the way to the following storm season, so for at least a year. We also studied metals, and this was a collaboration with the Colorado University Boulder. And metals, not too surprisingly, were also elevated in concentrations compared to pre-fire levels, sometimes up to 3 orders of magnitude higher. Interestingly, these metals rarely exceeded EPA guidelines for aquatic health. So we saw, in summary, a clear increase in nitrogen export from burning. We did see an increase in metals, although not necessarily harmful, according to EPA guidelines. And as far as organic contaminants were concerned, we did see that there was a clear impact from the fire that was not too dissimilar from the type of open pit municipal waste incineration that used to happen. So some high levels of chemicals such as pentachlorophenol or PFAS, and these were, some structures were hot spots, and they were long lasting. They also lasted for over a year in the system. So this first NSF Rapid grant, this first collaborative NSF, was actually the starting point for 2 other rapid grants that followed. So I'm going to tell you a little bit more about this first one that was with a team of synthetic biologists at Northwestern University who developed cell-free RNA sensors that develop they generate a fluorescent signal in presence of water contaminants. And this collaboration involved field testing of their sensors in Paradise, the spring following the fire. And that also led to a nice Nature Biotech publication. And I'm going to give it back to Jack to tell you about the next one.
Thank you. Yeah, we've continued this work, and we have another proposal right now looking at nanoparticulates. This is also a rapid based on last year's fire. So yeah, it's been, there's so many of these fires happening. And if you look across, the North State, and particularly the watersheds around Chico, we continually see more and more fire. And if you don't think this is affecting you, at the bottom of this watershed is Lake Oroville, which is the largest drinking water reservoir in California. So even if you're in Southern California, this is where your water is coming from. And, so we anticipate that, this work will continue. And really it did all kind of start with getting that first rapid. So with that, we'll turn it back over to Q&A.
Great. Thanks for a very, very interesting talk. And it's very interesting how you kind of combined all these different rapid funding proposals and projects. So I'm going to go a little off a little bit and ask you about that mechanism aspect of it. With respect to that, how do you choose if you continue on in a rapid type mechanism of trying to secure funding for your projects, or go to the traditional route, maybe RUIs or other types of programs that NSF offers? I'm just trying to gauge, because it seems like you're doing real well in securing rapid. You kind of open the door, you have your foot in there, and now you seem like you have 2 feet in there now. And I understand that rapid are not always available, because it really is based on what emergencies there are that are out there in terms of the country, wildfire, storms, tornadoes, hurricanes, etc. But how do you make that strategic decision, or do you try to leverage the rapid to try to secure funding from other types of programs?
Yeah, I can speak to that. And I guess, we are doing both. I mean, I think we do have a strategy to go after larger, long-term funding. But the rapid is very well suited for responding to natural disasters, as you mentioned. So if you look at a lot of disasters, because they're unpredictable and it is a response, the rapid is just a very good mechanism for funding these. And we haven't led each of these. We led the first one. It was a Chico State-led collaborative rapid proposal. But the other 2 have been us joining forces, because we're on the ground in California. When people know that we're here and we can get the work done, we're able to go out and sample and leverage our capabilities at Chico State out in the field, and then collaborate with others who are seeking the rapid funding. So yeah, we're doing both. I mean, I think we are strategizing for more long-term, more controlled science around wildfires as well.
Great, thanks. I mean, I always say that's if you can't lead a project, then find a collaborator, and if that collaborator can lead and you, I don't know, sit in the back seat. Not that you're sitting in the back seat, but big projects, even a little bit of a big funded project is still a lot of money. So, who's going to turn a lot of money away? I certainly didn't. I kind of, through my career, had a lot of sub awards, and with R01 institutions, and they provided a lot of funding for students during all those years that I conducted research. So really, thanks for a very inspiring presentation, and good luck to both of you. Great, thank you. Our next speaker is Hope Johnson from Cal State Fullerton. Her talk is entitled Manganese Phototrophy in Bacteria from a Sabbatical to an EAGER. Hope.
Thank you. Thanks for inviting the invitation, and thanks to all of you out there listening. I'm going to tell you a little bit about what my lab does. So we're interested in manganese oxidizing bacteria because of the important role that they play in biogeochemical cycles on our planet. In particular, we're interested in the bacteria that can take soluble manganese-2, the transition metal manganese, and oxidize it to manganese 3 and 4 oxides, which are insoluble precipitates. These oxides have an amorphous nature that allows them to sequester heavy metals, and they're also some of the most oxidizing compounds in nature, and they can oxidize other metals, such as iron and copper and uranium. They can also oxidize sulfides and recalcitrant carbon compounds. These capabilities of the manganese oxides make them useful for bioremediation, and thus the manganese oxidizing bacteria have the potential to be used for bioremediation. So in 2015, I was very happy to be doing a sabbatical in Woody Fisher's lab at Caltech. Woody Fisher and I share an interest in pretty much all things manganese. And so it was a great opportunity to collaborate and work with somebody who has such a strong interest in the things I'm interested in. One of the things I was able to do during my sabbatical was to dig in deep into the photosystem 2 literature, which I had been very interested in and wanted to do for a long time, because I was interested in whether cyanobacteria could oxidize manganese. And during my time there, I was able to set up some preliminary screening experiments that turned out to give us some good data. And we decided we wanted to continue this work in collaboration and started to look for funding. So one thing I should note is that Woody Fisher is a geologist and I'm a microbiologist. So we had some really different expertise that we were able to bring to this project. So we initially inquired about EAGER funding because of the risk involved in our project that we thought, but unfortunately there weren't any funds available for EAGER, so we could not apply through that mechanism. So we were encouraged to apply through the IOS, which is the program that we contacted to submit a pre-proposal, and then we submitted a full grant proposal. Unfortunately, that was not funded, so we got as much as we could out of the reviews and turned it around and resubmitted again. And this time we got really great reviews, but unfortunately we still weren't funded. But, calling up the program director to find out more information about what we could do to improve, we learned that EAGER funding was now available and it would be perfect for us to apply for that. So of course we did. And luckily enough, we were funded and super excited about that. So now I'm going to tell you a little bit about the project that was funded. One of the things that has changed, basically our planet and all the life on our planet is the evolution of oxygenic photosynthesis. So the production of oxygen by photosynthesis, and that originated around 2.3 to 2.4 billion years ago. And this really changed our planet in terms of the chemistry, but also in terms of biology, led to new metabolic pathways, and especially an abundance of energy through respiration with oxygen. So that extra energy led to diversification, a large amount of diversification, as well as multicellularity. The ability for us to even live on this planet, we can trace back to cyanobacteria gaining the ability to do photosynthesis and produce oxygen. So this is an important event in Earth history. And what we are interested in understanding is this enzyme photosystem 2. So photosystem 2 is responsible for oxygenic photosynthesis. And what this enzyme complex does is it extracts electrons from water and as a byproduct produces oxygen. These electrons are then excited by light and can be used in an electron transport chain for the cell to get energy, as well as for biosynthesis. There's another type of photosynthesis that some bacteria do called anoxygenic photosynthesis, and that's very similar. Light is activating an electron to be used for electron transport chain and for biosynthesis. But the electrons, they come from compounds like hydrogen sulfide or reduced iron or reduced organic compounds. So the reason I mention that is because the Ancestral reaction center is thought to be anoxygenic, And an oxygenic reaction center was similar to the modern day anoxygenic photosynthesis. We think it could do low potential reactions. By low potential, I mean that it was relatively easy to extract electrons from hydrogen sulfide, for instance. So that ancestral reaction center evolved to the photosystem 2 that we know today in modern times in cyanobacteria and plants. And this photosystem 2 produces oxygen, but this is a high potential reaction. And by that, I mean that it's very difficult to extract electrons from water and produce oxygen. So this is a much harder reaction. And so if we think of evolution as being stepwise, we would think there would be some intermediate in going from a low potential reaction to a high potential reaction that also could produce oxygen. And we think that that missing link is manganese phototrophy. So manganese phototrophy would be using manganese 2 as an electron donor for photosynthesis. So why do we think that? We think that because of a lot of reasons from different areas, some structural and biochemical reasons, primarily focusing on this water oxidizing cluster. So photosystem 2 has this inorganic cluster composed of manganese and calcium ions. And this is integral and 100% required for water to donate its electrons for photosynthesis and produce molecular oxygen. And in that process, those manganese ions are actually getting oxidized. So it makes sense that manganese might be an intermediate electron donor for photosynthesis. Geological studies from Woody Fisher's lab have suggested that manganese was oxidized prior to the rise of oxygen. And one way that could happen is through a manganese photosynthesis. There's also a physiological reason to think that manganese might be involved because oxygen is toxic. We all have antioxidants that protect us and oxidizing enzymes that protect us from the strong oxidizing power of molecular oxygen. So if an organism evolved that capability, it would be toxic and potentially killing itself unless it had some kind of inherent mechanism for protection. Turns out that manganese can be that inherent protection. So cells that had an abundance of manganese or were storing manganese or were around manganese could be protected from reactive oxygen species that are produced by oxygen. So to show this, we wanted to show this on different levels. We used a model organism, Synechocystis PCC 6803. This is a cyanobacterium that's used to study photosynthesis. So we used that organism and tested and screened a whole bunch of different conditions to try to find one in which manganese was oxidized. And we were able to show that cells oxidize manganese as well as photosystem 2 purified from these cells. We saw that this reaction did not occur in the dark. It did not occur in the presence of DCMU, which is an inhibitor of photosynthesis, oxygenic photosynthesis. It's an herbicide that's commonly used. So we are pretty excited about this, but we wanted to go even more that would be suggestive of potentially an ancestral photosynthetic mechanism. And so we also looked at this mutant in photosystem 2, this D1D170A mutant. And what's special about this mutant is it can no longer produce this water oxidizing cluster. So without the water oxidizing cluster, this enzyme is not able to produce oxygen. And so we can remove oxygen from this reaction, the production of oxygen and all the potential reactive oxygen species that might be formed. And it would be something that we would think would be similar to that missing link, the step in the evolution to photosystem 2. And we were able to get manganese oxidation with this mutant enzyme. It was inhibited by DCMU. It also didn't occur in the dark. And so we think this is a good evidence that there is a potential manganese photosynthesis prior to oxygenic photosynthesis. So yes, we think that manganese oxidation and manganese phototrophy is likely the missing link in the evolution of photosystem 2, which completely changed our planet and the life on our planet. Some implications for these findings are, as I mentioned, evidence for potential ancient phototrophic manganese oxidation. Manganese oxides in geology are used as a proxy for the presence of oxygen. And now we have identified a process that oxidizes manganese in the absence of oxygen through photosynthesis. So these oxides are no longer good proxies for oxygen in the geologic record. It's also expanded our view of what type of organisms can oxidize manganese and what type of enzymatic mechanisms are possible to do this reaction. And cyanobacteria are incredibly prevalent on the planet, and so that changes also the prevalence of the ability to do manganese oxidation. And manganese oxidation is important in terms of biogeochemical cycling and the cycling of nutrient and trace metals, even on the micro scale on which organisms would be using them. It also points to a cryptic manganese cycle that's likely to be present in many environments with cyanobacteria. We know now that cyanobacteria can oxidize manganese, but we also know they can reduce manganese. So they may be doing their own cycling of manganese. And with that, I would like to thank all of you as well as my collaborators, Woody Fisher, Usha Lingapa, and John Magyar at Caltech. It's been super great to work with them on this project, as well as NSF for funding the project, as well as the Cal State Fullerton Incentive Grant, and my entire laboratory of undergrads and master's students at Cal State Fullerton. In particular, I want to point out Yvonne Dimagiba, and as she did some of the work that I presented today. So thank you everybody for your attention. I'll be happy to take any questions.
So thanks, Hope, for a very interesting talk. And given my inorganic chemistry roots, it's really nice to see crystal structures and transition metals in a presentation that STEMnet does, given all the work I did in my graduate school years at UCLA. So in terms of the EAGER process, and I know I mentioned early on in the intro that you need to have some sort of contact with the program officer before submitting prior to, as an EAGER mechanism proposal. Was this for you a seamless process? And what types of hints might you give to the audience who wanted to go via this mechanism?
I would not say it was seamless. I mean, the program director that I spoke to was really great, but there was no money available for several years to get EAGER funding. And so that wasn't even an option just because of funding or the availability for EAGER. So it was really imperative to talk to the program director regularly when we were submitting and when we got the reviews back. And so that when money was available, she was already thinking about us and of our interest in doing this type of grant.
Okay, great. Well, I guess in that case, you have to hope that the POs don't change, because if they do change, then you have to make sure that they pass that information on to the next person, huh?
Right. Luckily, it did not change over the time that we were trying to get the grant. The person did not change.
Great. Thank you, Hope, for a nice presentation. Okay, and good luck to you.
Thank you.
Our next speaker is Andrew Danowitz from Cal Poly SLO, NSF Rapid Project, Engineering Student Mental Wellness during the COVID-19 pandemic. Andrew.
Thank you for that introduction. Right. So today I'm going to be talking about the process of getting my NSF Rapid Grant, but also a little bit about engineering education, how I got into the field, and some of the preliminary results with the grant. So the first thing you might notice is that my research sounds maybe a lot more qualitative than some of the other technical hard science research that you've seen today or that you might expect to see at a STEMnet talk. And in fact, my research these days does tend to follow along more of a social science type route, looking at engineering education and trying to improve engineering student success. Now, before becoming a professor in 2014, I had a very firm technical engineering background. So this transition may not seem like a natural fit, but for me, I look at engineering education as an engineering problem, especially being in the CSU, where our focus is on primarily undergraduate student success. I see my job, my process to optimize as how do I successfully educate a diverse group of students in my case, in engineering topics related to computer engineering and electrical engineering, and how do I give these students a passion for engineering to keep them on track for graduation and in the field after they graduate. Now, unfortunately, my own personal experience, the experience of my colleagues, and many studies confirm that engineering programs tend to have what we would call in process engineering a very low yield. Many students who start out intending to graduate in engineering, and also many other sciences, leave the programs either to different majors or leave higher education altogether without a STEM degree. And this is particularly true in the sense that engineering programs nationwide have not been successful in improving graduation rates for historically marginalized groups. Also, even among those people who do graduate, many eventually leave the field of engineering. So for me, engineering education is a way to optimize my process. How do I fix and the experience of my colleagues? And many studies confirm that engineering programs tend to have what we would call in process engineering a very low yield. Many students who start out intending to graduate in engineering, and also many other sciences, leave the programs either to different majors or leave higher education altogether without a STEM degree. And this is particularly true in the sense that engineering programs nationwide have not been successful in improving graduation rates for historically marginalized groups. Also, even among those people who do graduate, many eventually leave the field of engineering. So for me, engineering education is a way to optimize my process. How do I fix and improve this system for better efficiency? Now, for those of you considering going into engineering or STEM education, I found that there are many different entry points into the field. I started out by trying to create and develop cutting-edge new courses, bringing in exciting new materials and projects to motivate students. And getting publications in this area enabled me to start going to engineering education conferences, seeing what else was going on in the field. And from there, I moved on to some student evaluation, formative assessment rather than summative, classroom management techniques, improving group work, etc. And also more into topics like the one my Rapid grant is on, improving inclusivity and accessibility for all students, especially those from different backgrounds in engineering education. In engineering education, there's also a fair bit of funding available. One that I wish I knew about when I was first starting out is the NSF REEF proposal, Research Initiation in Engineering Formation. And this allows new researchers who want to get into engineering education research to apply for some startup funds from the NSF and work with a more senior engineering education researcher on a project. Where I started out in the field, I went with an external collaborator, Dr. Casey Beddos, who's currently affiliated with the Engineering Dean's Office at San Jose State. We applied to research in the formation of engineering directorate at the NSF. And we're able to get a 3-year grant of $300,000 looking to see how mental health and wellness in engineering students varies across different engineering populations, and if any mental health or wellness issues are good predictors of retention or lack of retention for certain student populations. And this work really positioned me to get the RAPID that I'll be talking about today. As Frank already mentioned in his introduction, RAPID grants are used whenever a sudden event comes about where the urgent need to collect data is enough, well, the need to collect data is urgent enough to circumvent the full NSF grant review process. So these are grants decided largely by program officers designed to get through the system quickly so researchers can start studying. And in my case, the precipitating event was the COVID-19 pandemic. The first news that came of COVID-19 to the US was probably late 2019, but even then I don't think many of us were prepared for how quickly it would come to the US and really upend the academic experience for our students, but especially for engineering and STEM students who tend to rely a lot on in-person lab access, collaborative project-based learning in labs with specialized equipment, and a lot of campus resources to support them through their program. So when it became clear how much of an impact COVID was having on the learning environment, our NSF program chair for our RFE actually reached out to my collaborator and I and asked if we had any ideas to study the effects of COVID-19 on mental health. Because we already had a good relationship with our program officer and he had seen some of our yearly reports on mental health, he knew that we had some expertise in this field. We had good relationships with IRB. We're able to get surveys out quickly, and we have mechanisms for getting surveys out to students nationwide. From that invitation, we submitted a 2-page proposal designed to look at how COVID impacted life stress for engineering students nationwide, and also how it affected overall mental health. And we were able to get the funding and start collecting data within a few weeks of submitting the 2-pager. So now that I've talked about my entry into the NSF Rapid, I'll briefly talk a little bit about the research and some of our preliminary results. We sent out a survey nationwide to engineering students from May to July 2020 using a life stress event scale and population scale mental health screens to see how COVID was affecting things. Because we went nationwide, we were actually able to get a sizable, statistically significant number of students from a number of different historically marginalized, historically excluded backgrounds. And of course, engineering being what engineering is, we also got plenty of white male students as well. Overall, we got about 670 responses from engineering students at 4-year nonprofit institutions representing over 100 schools. Looking at life stress events and doing some logistic regression to see which groups tended to be more likely affected by certain events, we were able to see that Latinx students specifically tended to be overrepresented or tended more often to be more likely than the baseline population to experience certain life event stressors as a result of COVID-19. We also see that international students, while they're only overrepresented, more likely than non-international students to experience life stress events for 3 different things, they tended to be overrepresented for some very serious stressors, like ending a serious romantic relationship and death of a close friend. Now, all of this indicates that these groups may need extra support, especially as campuses reopen and students who have experienced these stressful events, these traumas, are trying to get back to normal campus life. Looking at mental health screens overall, the biggest change that we saw from our pre-COVID pandemic numbers was in the prevalence of depressive disorders. Pre-COVID, our participants were screening positive for depressive disorders about 25%, about the same as anxiety. Post-COVID, about half of our respondents were screening positive for some sort of depressive disorder. Now, this was interesting because we didn't see any corresponding increase in anxiety diagnoses, and usually depression and anxiety are correlated. But this is also very concerning because conditions like depression have been linked to lower grades, less academic performance, and if half of our students are facing this, trying to reintegrate and graduate, this may spell bad news for retention or present challenges for retention of engineering students for the next few years, and may indicate that universities need to start spending a lot more effort in this area. To wrap things up, if you're interested in more of our research, all of our publications are available at sociologyofengineering.org. That's my talk. Are there any questions?
Hi, Andrew. Thanks for your presentation. Very, very interesting. And it certainly is very timely, and especially in the engineering field. Maybe give us a little more background as to, do you have any formal background in engineering education before you started research in this area?
I really didn't have much. I knew I wanted to teach, but my PhD was a traditional technical route looking at VLSI and computer architecture. At my grad school, I did take one course on education, engineering, design, and I TA'd a few times. But for the most part, most of my learning was once I entered the field. I found many of the other researchers, unlike in some of my competitive technical journals, the other researchers were eager to collaborate, eager to help, very welcoming community. And I think that's one thing that really attracted me to the field. And it's one reason why I would encourage anyone out there to also consider getting involved in the education research field, because we can do a lot of good, and there are people out there willing to help train you up and collaborate with you on projects.
So like there are degrees in and campuses are hiring in, say, bioeducation, chemical education, physics education, and these people have degrees, they're formally trained in, for example, chemical education. Can one get a PhD in engineering education?
That is increasingly possible. Historically, the main place you could do that was Purdue, and you do see a lot of influence of Purdue-trained individuals in the engineering education field, but a lot of people still go the technical route like I did and transition over as we get more involved in teaching, especially those of us who end up at primarily undergraduate institutions. So it is possible, but it's still pretty rare.
Okay. Well, certainly you're filling that niche that certainly is needed and really apropos for the CSU, given our mission. So thanks, Andrew. So next speaker is Amy Dow from Cal Poly Pomona, and her talk is entitled, How Do Multigenerational Households Navigate Care and Safety During the COVID-19 Pandemic? Amy.
Thank you so much, Frank and STEMnet, for inviting me to be part of this webinar. I am a cultural anthropologist, and I'm broadly interested in how social and structural factors shape human health. Today, I'll be talking about my project, giving a little overview, and then also a little bit of behind the scenes in terms of how I applied for the EAGER. So by way of introducing the project, I'd like to tell you a little bit about my mom and dad. Here they are in the 80s, looking very young and cute. They both came to the U.S. As Vietnamese refugees in 1980 with very little money and resources. So after scrimping and saving and sharing one-bedroom apartments with their respective siblings, they were able to buy a three-bed, two-bath, 1,300 square foot house in San Jose, California for $135,000 in 1986. And throughout my childhood, we weren't the only ones who lived in the house. We actually practiced multi-generational household living, meaning that 3 or more family generations lived under one roof. We also practiced multi-family housing arrangements, so more than one nuclear family under one roof. So for a period of time, my aunt came to live with us while she was in school and after she graduated, so she moved out when she got married. Then my dad's youngest brother came to live with us to help my dad take care of us kids. Then next, a family of 3 actually came to live with us. They were my parents' friends from Vietnam, and they had just migrated over to the U.S. And after they moved out, my grandfather lived with us. He had just also come from Vietnam, and my parents were taking care of him. So there were a lot of benefits to living this way. Economically speaking, we all saved money. My parents got, essentially free childcare, and our quality of life was pretty good. Even though the house was crowded, we had a yard, we had nice neighbors and a school nearby, and I got to know the family members really well. So if we fast forward to 2020, multi-generational living arrangements are actually on the rise, but all of the benefits, which helped my family and no doubt the many other immigrant families now in the U.S., these benefits have transformed into sort of a high-risk living situation due to the COVID-19 pandemic. So if you look at the CDC recommendations for preventing the spread of the coronavirus, they're really geared towards individuals and also public spaces, rather than families and private spaces. So how easy is it to physically distance or isolate when you share, a 1 or 2 bedroom house with multiple people? How easy is it to wear a mask all day when you're at home, a place where you're supposed to relax and settle? And also, if the recommendation is to stay at home when you're sick, then what does home mean when the coronavirus is most likely spread in households? And this is especially true for multi-generational households that have grandmothers and grandfathers who are elderly and immunocompromised. So beneath the dangers of the coronavirus, there are other social conditions that have led to certain populations who are more likely to become ill from this disease. So as of 2016, 20% or 1 in 5 Americans live in households just like the one that I grew up in, the multi-generational household. And this is not really surprising, right? Because housing prices have gone way up in the US, and especially in California. And also the percentage of single-family starter homes being built in the US is also shrinking. So you have like major supply issues. And so now when we look at my parents' home, which was $135,000 in 1986, it's now actually estimated to be $1.4 million according to Redfin. And the median household price in California particularly has shot up at least $100,000 from 2020 to 2021, if we're just looking at these last 2 years. And California in particular is ranked number 2 just after Hawaii in the highest proportion of multi-generational households. So add to that mix another factor, which is that essential workers are more likely to live in overcrowded housing, which brings in sort of another element of infectious disease risk for multi-generational households, which tend to be more crowded. So the phenomena then that we're seeing, just to repeat, is that these sort of economic survival strategies that people like my family used back then and people using now have become these sort of high-risk situations. The things that were socially and economically beneficial are now becoming sources of health risk. And so given all of these social and economic factors, then our research question is, how do multi-generational households navigate care and safety during the pandemic? And our research study is ethnographic in design, and we are sampling from Latinx, Filipino, and Vietnamese households because these groups are most likely to practice multi-generational arrangements, according to this Pew Research study. So as you can see, multi-generational households are on the rise in every ethnic group, but mostly with Asian and Hispanic Latinx groups. These groups are also the primary groups that have been negatively affected by the pandemic. So here's a snapshot of the LA County dashboard on COVID-19 deaths. And you can see that Latinx experience significantly higher mortality rates compared to other groups. Similarly, if you disaggregate Asian American data, you'll see that Filipino and the Vietnamese populations experience a higher share of mortality compared to their share of the population. So one exciting thing about this project is that that I'm running it through my Methods in Anthropology course through a course-based undergraduate research experience, or CURE. Students right now are recruiting participants in and around LA County, and I am training them on a variety of methods that are ethnographic, including in-depth interviewing, participant observation, free listing, card sorting, and hypothetical situations. We are still in the process of recruiting. So if you or a friend fall into any of these eligible categories and are doing the multi-generational living thing, feel free to reach out to me if you're interested in being part of the study. But to sum up then, the goals of the project are to investigate the family dynamics, and upstream structural issues that contribute to household health during the pandemic. because it's a EAGER grant, we want to build a research design model for researchers evaluating risk for disease transmission within multi-generational households where disease exposure is higher, but members are frequently less able to adhere to common public health guidelines. We also want to contribute to more, we're hoping that this research will contribute to more effective public health by gathering information about the challenges that are specific to multi-generational households in the context of the pandemic and infectious disease in general. And then lastly, of course, is to provide an authentic experience to students through the CURE following Cal Poly Pomona's Learn by Doing model. And so a little bit of behind the scenes about applying for the EAGER. So my EAGER was funded through the Research and Undergraduate Institutes program, which is specialized for CSU type schools. And it was reviewed by the Cultural Anthropology program. So here I'd really like to emphasize how incredibly helpful the program officer in the discipline were for me. I'm currently in my 4th year, and this was my first time applying to an external grant at the professoriate level. So it was a good learning curve. And my collaborator and I, so then we developed this project starting in October. And then during that semester, I didn't have any course releases for research, but in November, I did sit on a review panel for NSF, and that's when I approached the program officer about this project. And the program officers were like, oh, it sounds good. Send us your 1-pager. Then about 4 months go by, and it's spring semester, and this time I did have a course release through the Teacher Scholar program, and I was able to put together the 1-pager. And they replied asking me to send a draft budget and a more detailed description, which I sent in April. That's when the program officers suggested that the projects could be funded through the EAGER mechanism, and they told me to apply through the RUI as well. And that's when I reached out to several colleagues who had RUI funding to get copies of their application. And then I made the final submission in June and then heard back unofficially in July and got the official letter in August. So my takeaway, I guess, is, we had the research idea, but it was really the program officers who laid out the path in terms of where to go to get funding. And so my biggest tip would be, talk to your program officers and sort of trust in their creative ability to help you. And thank you so much, everyone, for taking the time to listen to my project or my presentation.
Great. Thanks, Amy, for a very, very interesting presentation. And I'm going to date myself here. But, when I was in grammar school, I remember seeing a lot of young people who eventually were my friends because it was post-Vietnam War come into my school, both in the middle school and then in high school. And, when you're young, you don't really understand, what's happening from a global perspective. But I remember seeing a number of these, new people, come in and starting in school, not when we always started, in September. Now it's August because everything's changed now. But they would just start, whenever, December, March, January, and here's this new student, and sometimes they didn't know English very well, so it was neat to kind of see how they, integrated within the mainstream fabric of America. But when you're young, you don't really understand what's going on in the global perspective.
Yeah, well, the global touches the local, right? And it's interesting to then...
All politics is local. Yeah, yeah. So what difficulties, and this really goes across all the CSUs, what difficulties did applying as a PUI pose for you?
So I, because the program officer was so good about telling me which programs to apply for, I actually thought that being a PUI was an advantage because the RUI mechanism is specifically created for schools like the CSUs. You're still reviewed on like the same merit as other NSF projects, but the RUI is sort of like this sort of extra funding mechanism that is specifically for schools like us. So I don't think that the PUI actually, our PUI status actually held me back. It was, I think, actually pretty good.
Okay, great. Well, thank you. And certainly to everyone for your wonderful presentations. You did a fabulous job. Speaker contact information is provided here. For more information on any of the presentations, please contact the speakers, as this could lead to a collaboration or a proposal opportunity. In addition, a link to the webcast will soon be made available on the STEMnet website. For more information on this webcast, as well as others, please contact Monica Alarcon, Administrative Analyst for STEMnet, or myself. And as I said, you can find all of our previous webcasts, as well as podcasts there also. STEMnet's always looking to write and work and facilitate collaborative proposals across the CSU, and we've written a bunch of them over the past year and a half. So if you have an idea for a project, please send me an email. And finally, while for months our institutions of higher learning shut down for in-person instruction due to the pandemic, innovation did not and could not stop. Instead, the pandemic accelerated the transformation of higher education, pushing us forward and at warp speed. What emerged was an environment that not only showed our resiliency, but our ability to be more flexible, highly personalized, and more focused on outcomes, well-being, and lifelong learning. This new environment has set the stage for the building of a new student experience. Virtual learning has allowed us to revisit traditional ways of teaching and engaging students. Improving access and understanding of today's technology is a short-term need. Making smart decisions now for future technology investments will set the stage in coming years and will make up for that long-term need going forward. The acknowledgement that students do not learn in the same way or pace, and that many have work and family responsibilities due to the pandemic, has led schools to accommodate these differences with more flexible learning options. Personalized learning will become the norm and will be made possible by the adoption and creation of technology. It is important that there is an understanding between the real and perceived value of a college education. There is a disconnect between students and faculty and school administrators about how much it should cost to go to college. In the future, an educational experience involving skills development and lifelong learning will deliver the highest value to students in a post-COVID world. The pandemic shifted us away from the traditional on-campus presence and also brought to light the fractured nature of college life services. Going forward, programs will need to be forged together in a seamless delivery model so students can access these services as needed wherever they are and on demand. Beyond academic content, the value of a college education also includes meeting the need for on-demand personalized academic services. It is also critical that schools provide students with practical skills to enable lifelong learning and growth, such as soft skills, career skills, health, and well-being. Our world will forever be marked by COVID-19, and few areas of our lives will return to exactly what they were prior to it, nor should colleges and universities. Instead, higher education should be using the learnings of the last year to further bolster their efforts to define and reshape the student experience. The road ahead for higher education and the substantial transformation it will encompass is undoubtedly going to be faced with challenges. But the road ahead also presents profound potential with significant opportunities for growth, improvement, and innovation. Finally, to all of you, may you have a safe day, and may the rest of your day be a happy one. I now turn it over to our own Jennifer Wicks for a few closing remarks.
Thank you very much, Frank. Just want to mention a few announcements as we wrap here. I know Monica will be placing in the link for the webcast feedback survey. If you would, Monica, that would be really helpful. Or you can also take out your cell phone and just snap a picture of that QR code. It'll take you directly to the feedback survey. Also, please do join our STEMnet community listserv and also the Facebook group. There's conversation and dialogue that happens over there as well. And those two links are active. Feel free to click on both of those. They'll also be in the chat in just a moment. And the STEMnet Virtual Research Cafe 10.0 is going to be November 19th, 11 to 12. You can register there by capturing that QR code or clicking on the link that will be pasted into the chat momentarily. And also our next webcast in this series, the STEMnet webcast series, will be December 3rd as we move into the holiday season from 10 a.m. to 12 noon. And that will be on the National Science Foundation CSU Geo Directorate Programs and Awardees webcast. So please do register for that as well. Look forward to you joining us. And thank you again for your time and for being here and listening to all these excellent presentations. And thank you again to all of our presenters and grantees who joined us for this excellent webcast today. It's so great to hear all of the success that's happening across the system. Please do click on that QR code or visit the website. We have all the recordings there. Monica Alarcon is putting all of the PowerPoints, making those available as well. It's a huge place for resources all about STEMnet in the CSU. So thanks so much. Have a wonderful rest of your day, and we look forward to you joining us later in this month for the cafe, and then December 3rd, we'll see you for the next webcast in the series. Thanks, everybody. Have a great day.